Okay. This work is on trapezium rule, and so we start with using the trapezium rule with strips of width 0.5, falling off, to find the approximate value for the area of the region bounded by the curve y equals square root of 4x plus 1. Okay, so we do our little table for this. Thank you. It says strips of width 0.5 between the lines x equals 1 and 3, so we're going to start with 1. I'm going to do a table. I like doing tables. 1.5, 2, 2.5 and 3. And we do it in our two columns. Y is the square root of 4x plus 1. Now we don't really need to, but these are such simple numbers that we may as well kind of work with the exact values in our table here. We would have root 5, wouldn't we? There. 4 times 1 plus 1. 4 times 1.5 plus 1 is root 7. Then we'd have root 9, which is 3. Then we'd have root 11. And finally we would have the square root of 13. And now the formula for the trapezium rule is on the formula sheet. It says the area is approximately equal to a half times the step size. Now quite often when we did our examples of this we had a step size of 1, didn't we? But in this case it's a half, isn't it? So times a half multiplied by the first plus the last plus twice the others. There we go. And so if we add that up, notice that the question did say give your answer to 3 significant figures. So that's what we need to do. 0.5 times 5 times 5 plus root 3 plus twice, oh it's not 3, it's 13, sorry. Plus twice root 7 plus 3 plus root 11. I'm pressing the wrong buttons here. Close brackets. What do we get? I got 5.94 as well. There we go. Square units. Although you don't need to write that. Now, state with a reason whether this approximation is an underestimate or an overestimate. So there's our curve. They helpfully drew it for us. What did we think?
Underestimate.
Underestimate. Why?
Because the curve goes over the trapezium.
Okay. So for part 2 we're going to say it's an underestimate. Is that all one word? Because the curve curves over the tops of the trapezium. And I'm not sure, maybe it should be trapezia. I don't know. If you want to, you can draw a little diagram to show there's a trapezium and there's a curve going over the top of it. It just makes it really super clear. Great. 6 marks. The second question, more serious integration this time, for 9 marks here. The graph, the diagram shows y equals 4 minus x squared on the line y equals x plus 2. Find the coordinates of the points of intersection. Well, notice how we're just doing a bit of core 1 stuff here. To find the point of intersection, we're doing simultaneous equations, aren't we? And we're going to equate the y values. So 4 minus x squared equals x plus 2. Now I'll take everything over to one side. I've got x squared plus x minus 2, which if we factorise gives us that, I think. And does that look about right according to our graph? I think it probably does, doesn't it? We've got x values of -2 and 1. That looks reasonable from what we can see of the graph. And we know that this curve crosses at plus or minus 2 anyway, so that makes sense that that's -2, and that looks like it's about halfway. Right, use integration to find the area of the shaded region bounded by the line and the curve. Well, there's a few different things we could do. We could, if we wanted to, recognise that there we have a right-angled triangle, and so we could find the area of that right-angled triangle, and find the area under the curve, and then subtract the triangle from the curve. That's quite an easy thing to do. Or we could do the whole thing with integration, and think that what we're doing is we're taking the thing on the top, which is the curve. So we're doing the curve from -2, up to 1 of 4 minus x squared dx, and we're taking away the straight line, x plus 2, between -2 and 1. Can you see what we're doing there? We're doing, the integral is the whole of that shape, and then afterwards we're finding this shape in here, and we're taking away the bottom shape from the whole thing, and that leaves us with the shaded bit up there, which I think is pretty neat. Right, so I would probably do this way, and I'd probably do, at this point, a thing where I brought all of this together, all of this together as one integral. So I've got 4, I've got 4 minus 2, really careful with the brackets now, which is 2, minus x squared, minus x dx, which if we integrate, what do we get if we integrate that? Go on, Brovia, what do we get if we integrate that?
2x minus x is 3 over 3 minus x squared over 2.
Very good. Between -2 and 1. And now we just sub the numbers in. So that is 2 minus a third minus a half. Take away -4 plus 8 over 3. And then -2. Because -2 squared over 2 is just 2. Which altogether leaves us with 4.5, 9 over 2. Is that right? Oh, good. There we are. 6 marks. Now, I don't mind how you did this. You could have worked with these 2 bits of integration separately. You could have worked with this one as an integration, and this one as a triangle. Found the area of the triangle and taken it away. Either way that you did that, you'd have got to 9 over 2, 4.5 as your answer at the end. That's it. And that's maths.